Hello friends, how are you? In yesterday class we discussed about tribal name system and then we discussed about derived name system, and before that we discussed about the hydrocarbons and their classifications. Okay, now in today's class I am starting IUPAC system. I am starting IUPAC system. It is very important for our exam. It is very important for our exam. Got it? Normally there is a chance to ask the IUPAC name of any organic compound, particularly in our syllabus, that is hydrocarbons. So the examiner can ask the IUPAC name of any hydrocarbons. Okay, so let me start about it. In this system, the name of hydrocarbon is written by using the prefix and suffix. This is the most simple part. One thing let me clear you, there are various rules and regulations of nomenclature in IUPAC, but it as at grassroots, or we can say that basic level, then we can consider the name of hydrocarbon is made up by two parts. The first part, that is prefix, which is based on the name of number of carbon atoms, while the second part, that is suffix, which is based on the number of bond, present in molecule. So we can say that the name of hydrocarbon is made up by two parts. First is prefix and second one is suffix. Prefix denoting the number of carbon atoms, while suffix denoting the type of bond present in that molecule. Okay, now there is a table which indicating the number of carbon atoms and the prefix for use for that. If there is one carbon, then math prefix is used, but if there is two carbon, then eth. If three, then prop. 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. Okay, if there is one carbon, then meth, two carbon eth, three carbon prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. These are the prefix which we use as the name as the number of carbon atom present in that molecule. Suppose a molecule has 3 carbon atoms, then we use prefix prop for denoting the number of carbon atoms. Okay, second, that is the second table, which is showing the suffix which is based on the type of bond. As you know, there are three types of bond between the carbon atoms, maybe single bond, maybe double bond, maybe triple bond. Single bonded are called alkanes, double bonded that are alkenes, and triple bonded that are alkynes. So there is three series. First is alkane, second is alkene, and third one is alkyne. Alkane, alkene, and alkyne. Got it? On the basis of that, if there is a alkene series or alkyne series or alkene series, the three suffix can use. If there is alkane, then ane suffix is used. If that is alkene, then ene, and if that is ine, then alkyne, then ine suffix is used. To more understand that, we can consider few examples. First one, there is CH4. It has one carbon, as it's showing that is only one carbon, so prefix is used meth. Since one carbon is always saturated, why? Because for making double bond or triple bond, we need at least two carbon, because as per the definition, alkenes are those which have double bond between carbon atoms. So at least 2 carbon atoms is needed. Similarly, alkynes, those hydrocarbons in which triple bond is present between the carbon atoms. So that means minimum 2 carbon atom is needed for alkene and alkyne. So one carbon atom is always is saturated. So that is meth for one carbon, and since it is saturated, so that is ene. So name becomes methane. Its name becomes methane. Got it? Understand? Now second example, that is CH3 single bonded CH3. Since 2 carbon, so that is eth. 2 carbon, that is eth, and 2 carbon are always such and there is a single bond between them, between the 2 carbon atoms. So ane, because of the alkane, so ane word is used. By combining them, its name becomes ethane. Similarly, in third example, again there is 2 carbon, so eth, but this time here double bond is present, and because of the double bond, that means it is alkene series. Ene suffix is used, so its name become ethene. Got it? In that example, there are 2 carbon, eth, triple bond present, that means alkyne series, so ine is used, so name becomes alkyne. Got it? This is the basic principle of IUPAC nomenclature of hydrocarbons. Got it? The more rules we will discuss in when we discuss about the alkene and alkynes. Okay, so now let's start the first hydrocarbon series, that is alkanes, or it is all, these are also called paraffins. These are also called paraffins. Firstly, consider the definition, then we can say that the saturated hydrocarbons, in which single bonds are present between carbon atoms, are called alkanes or paraffins. These are called alkanes. Got it? These are called paraffins because they are less reactive. That's why they are also called paraffins. Okay, now their general formula of alkanes, it is very important for exam. I am again repeating, it is very important for exam because it is the most common question on the hydrocarbons. They write the general formula of alkenes, alkynes, etc., and maybe ask the first 2 member, 3 member of that series. If we know the general formula, then we can make their series. That means the successive order of molecules. Got it? The general formula of these, that is CnH2n plus 2. CnH2n plus 2, where N indicating the number of carbon atoms. N is indicating number of carbon atoms. For alkanes, its value is 1, 2, 3, 4 and so on. Got it? Till to infinite. Now, with the help of this, we can derive the molecular formula. One thing let me clear you, that is molecular formula, and we discussed these that are structural formula. Got it? So the first of this series, the member of first member of this series is methane. And for meth, as the name indicating meth, that means 1 carbon, so n, value of n is 1. Now when we put the value of n in this formula, then it becomes C1H2, that is 2n, so 2 into 1 plus 2. Got it? So the answer becomes CH4. That is the molecular formula of methane. Similarly, ethane, for that eth, that means the number of carbon atoms is 2. So n, the value of n is 2. When we put the value of N2 in this formula, then that becomes C2H2 into 2 plus 4. C2H2 into 2 plus 2. Sorry, that is not 4, that is 2. So 2 into 2, 4 plus 2, that is 6. So its molecular formula becomes C2H6. The third member, that is propane. Prop, that means N is 3. When we put N is 3, then C3H2 into 3 plus 2. So its formula becomes C3H8. Similarly, if we consider the butane, then it is C4. For but, N is 4. So C4. Now put the value 4 here. So it becomes 2 into 4 plus 2. 2 into 4 plus 2. So its molecular formula becomes C4H10. So its formula becomes C4H10. Got it? So in this way, by using the general formula, we can derive the molecular formula of this series. Got it? Now, after that, let me discuss the rules of nomenclature of alkenes. Rules of nomenclature of alkenes. Okay. The first rule is select the longest chain of carbon atoms for naming. It is called main chain. It is called main chain. So firstly, select the longest chain, that means main chain. Got it? The atom or group of atoms which remain outside of the main chain are called substituents. The atom or group of atoms which are not included in the main chain are called substituent. Here let me clear you, main chain, that means not a straight line. It means end-to-end connected series of carbon. End-to-end connected series of carbon. Got it? Again repeating, here the meaning of main chain or longest chain, that means end-to-end connection of carbon atoms. It does not mean that a straight line. Clear? And in these examples you will understand about it. Here the first molecule is CH3 single bond CH2 single bond CH2 single bond CH3. If we consider the continuous series, then these four included. So this is main chain. Here none of the atom is outside or group of atom is outside. So it does not have any substituent. Got it? Now let me consider the second example in which 4 carbon atoms are connected continuously and fifth one is in the sideways. Here if we want to consider the longest chain, then we include only 1 because chain, that means connectivity, continuous. So these 4 can include. This remain outside. So that is main chain and that is substituent. Got it? Now this one example. Here 4 carbon atoms are connected like this. 4 carbon atoms are connected in this way and 2 carbon atoms are here. If we consider the longest chain, then the different chains are possible here. One, if we consider like this, then 1 2 3 4 4 atoms are included. But if we consider this one, 1 2 3 4 5, then there are 5 atoms are included. So it is the main chain. It is the main chain and it is substituent. Got it? Similarly, now this example. Here if we try to connect end to end, then we can consider 1 2 3 4 5. 1 2 3 4 5 6. 1 2 3 4 5 6 7. So longest one, this connectivity. So that is main chain. I'm again repeating, main chain, that does not mean that straight line. It means direct connectivity. So that is main chain, and these groups which remain outside are called substituents. Got it? This is the main part of nomenclature. We have to carefully select the main chain. Got it? Clear? The second rule is, if the two or more chains, if there is possibility of two or more chains having same number of carbon atoms, then the chain which has more substituents is considered as main chain. That considered as main chain. Got it? Now, suppose that is a molecule. These are same molecules. Just firstly clear these pencil underlines. Then you will consider that these are same molecules. Now, if we select the longest chain in this 1 2 3 4 5 6, that is, first possibility is this one, and if we consider like this, then 1 2 3 4 5 6. Is there any possibility? Yes. We can consider 1 2 3 4 5 6 also. We can consider 1 2 3 4 5. So the longest chains are 6 carbon atoms. Got it? Now, if we consider this main chain, then this group is substituent. That means here 6 carbon atoms are in main chain and one group that remain as substituent. But if we consider this is as main chain, then it also has 6 carbon, but it has two substituents, that one and that one. So it has two substituents, so it is selected as main chain, not this. Got it? Clear? Again repeating, if two or more chains having same number of carbon atoms, then the chain which has more substituents will consider as main chain. It will take as main chain, selected as main chain. Got it? Now the third rule, that is numbering of main chain. Because when we write the name of hydrocarbons, then we also write the name of substituents, and for that we have to mention the number of carbon atom where the substituent is attached to. So therefore, for example, this, when we write the name of this, then we have to write the name 2-methyl. Methyl, that is substituent, and it is attached on the second carbon, so it is 2-methyl. Got it? So for that complete name, we have to mention the position of substituents. Clear? That's why for that purpose we need numbering. Now there is a rule of numbering, and it is the numbering of main chain is done from that side. A chain has two sides. Which sides will we consider? It is based on substituent. The numbering of main chain is done from that side in which substituent get minimum number. in which the substituent get minimum number, that side is selected as mean chain. That side is selected for numbering. Got it? Firstly, discuss about that point. This is a chain. These are chains. Methyl group is attached here. If we start the numbering from that, then substituent get minimum number 2. But if we start that, then it will get number 3. That one. 1, 2. If we start from that, 1, 2, 3. So minimum number is from that side. So it is selected as for numbering. Got it? Now in this example, there are 6 carbon atoms and one methyl group is attached here. If we start the numbering from this, then 1, 2, 3, then the number of substituent will get 3. But if we start from this, then 1, 2, 3, 4. So from which side is getting the minimum number? That one. So the numbering is 1, 2, 3. Got it? Understand? We start the numbering from that side from which the substituent get minimum number. Got it? Understand or not? Now, the next rule is, if, firstly let me read it here. If two dissimilar substituents are getting same position, then alphabetical order is considered. That means the substituent coming first in alphabetical order will get lowest number. Got it? To understand this, these are examples. In the first example, the methyl and ethyl, that group is called methyl substituent. As we discussed in the derived name system, that is methyl and that is ethyl. M and E, which one comes first? That is E. So we have to start the numbering from that side from which it get minimum number. If we start numbering from here, 1, 2, 3. If we start numbering from here, then 1, 2, 3, 4. So which one is, in which numbering it getting the minimum number? This one. So that is numbering. That's from that side we will start numbering. Got it? Now this example. Here again methyl and that is ethyl. Methyl and ethyl. If we start the numbering from here, then 1, 2, 3. If we start from numbering from here, then 1, 2, 3. If it is getting numbering same number from both sides, then we select that side from which the other substituent will also get minimum number. If I start this one, then it is getting 3. If I start this one, then it is also getting 3. But if I start this, then methyl is also get minimum number. So the numbering will start from that side. Got it? Clear? Understand? Now the fourth rule is, the name of substituents are returned first. When we write the name, then the substituent name is returned first with its position. That means it is attached with the second number carbon, it is attached with the third number carbon, like this. Okay? But if a chain has different substituents, then their name are written in alphabetical order. Then we have to follow alphabetical order. Got it? Now this example, which we discussed, this here main chain 4, and that is substituent. CH4 substituent, the prefix for CH substituent CH3, that is methyl. So we write the name of substituent first. From which carbon it is attached? Add the second number carbon. So its name and indication will be 2-methyl. And then we write the name of main chain. Here 4 carbon, for 4 carbon that is but, and since that are saturated, that means single bonded, that is ane. So its name, main chain name is butane. Got it? So its complete name becomes 2-methyl. 2-methyl, because that is substituent. So write the name of first, that 2-methyl, then then the main chain name butane. So name is 2-methyl butane. Now consider the second example. Here the methyl and ethyl groups are attached. Alphabetically ethyl comes first, so we write the name of ethyl first. On which carbon it is attached? On third. So when we write the name, then we show 3-ethyl. 3-ethyl. And then second substituent, that is methyl, which is attached on the second number. So that is 2-methyl. And then main chain. Main chain has 6 carbon. So hex. Since it is saturated, so ane, that means hexane. Now add all of these, so name becomes 3-ethyl 2-methyl hexane. Name becomes 3-ethyl 2-methyl hexane. Got it? Understand? Now there is some substituents and their prefixes. It is very important for us, because if we do not have any idea of substituents and their name, then how we will write the name of hydrocarbon? So that is very important. If CH3 group is substituent, then it is called methyl. If CH2CH3, then ethyl. If CH2CH2CH3, then it is propyl. And if the mid of the propyl is attached, then it is called isopropyl. Similarly, if 4 carbons are like this, then it is called N-butyl. Now if chlorine is attached, then it is called chloro. If bromine is attached, then it is called bromo. Iodine, iodo. Fluorine, fluoro. NO2, nitro. These are some common substituents. Okay. Now if the chain has more than one type of substituents, that means more than one type of substituents are attached, or then one type of substituents, same substituents are attached, then we use mono, di, tri, etc. with their name. For like this, here same 2 methyl groups are attached, so here for 2-di word is used. Here same 3-methyl is attached, so the name is trimethyl. Got it? So if the number of substituent is 1, then mono, and there is no use of that word normally. If there are 2 same substituent, then di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10, that is deca. These words use with the prefix of substituent. Got it? Suppose if there is 2-methyl, then we use dimethyl. If there is 3-methyl, then we use trimethyl. If a molecule has 4 methyl substituents, then we use tetramethyl. Got it? Understand? To understand this, let me consider some examples. The first example is CH3, CH2, CH2C, and this carbon has two methyl substituents, and then this. If we select the main chain, this one, numbering from that side, because we have to give the minimum number to substituent. Got it? So numbering started from this. Since these are same, so both are methyl, so the name becomes dimethyl. Now we also have to indicate that where they are attached. Both methyls are attached on the second number carbon, so the name becomes 2, 2, 2, 2 dimethyl. Now main chain, that is 5 carbon, so pent, single bond, ane, so name becomes 2, 2 dimethyl pentane. Got it? Now let me consider this example. It is also called isooctane in tribal name system. This is a very important name because it can ask in exam that write the IUPAC name of isooctane, because in that question the teacher will hit two questions together. First, you know about the tribal name system and you know about the IUPAC nomenclature also. That's why it is important. Now here there is a chain of 5 carbon and 2 methyl are attached in the second one and 1 methyl is attached at third one. So there is 3 methyl groups. So the name is trimethyl. Got it? Trimethyl. Now where the methyl groups are attached? At the second, 2 are at second and 1 is at fourth. So it becomes 2, 2, 4. 2, 2, 4. That is the position of 3 methyls. So 2, 2, 4 trimethyl pentane. Got it? Now here there is a chain, main chain, in which two CH3 groups are attached at the second and fourth. So since 2 methyl, so that is dimethyl, these are attached at the second and fourth, so it becomes 2, 4 dimethyl. Now main chain 5, that is pentane. Got it? Now this one, here 3 methyl groups are attached at the second, third and fourth, so its name becomes 2, 3, 4 trimethyl pentane. 2, 3, 4 trimethyl pentane. Got it? The last rule: in writing the name of organic compound, a comma is used between the two numericals. If there is two numerical values, then we use comma, and hyphen between a number and alphabet, as we used here and in the previous examples. Since there are two digits, two numericals, so to separate them we use comma, and to separate numerical and alphabet we use dash. There is no sign between the alphabets, but between the numericals and the numerical and alphabet there are signs. That is comma and that is hyphen. Got it? In tomorrow class, possibility of tomorrow, we will discuss again about that, because it is a typical topic and we practice the examples. Okay, and before that, it's my request, or you can say that it's my I am giving you homework to learn these rules again properly, so in next class you will get the name easily and you can understand the rules more frequently. Okay, we will discuss in next class about these examples. Got it? Why their name becomes like this. Got it? So that's your homework, to learn these rules again. Hope you like it. Thank you.